Hey everyone, this video is going to cover member functions, but before you watch it, there are a couple things that you need to have done. First, you need to make sure that you've completed all the previous modules. You also need to have gone up through section 7.4 of the book, and also make sure you've seen the previous video. In the previous video, we created a house class, and then in the main function I showed you how we can access the public data within an object. I also said that you don't want public data in your objects. Your data should be private, and you should write public member functions which access that data for you. Those member functions are going to be what this video is about. Before we dive into member functions though, I'm going to show you how we can better organize our code when writing classes. In this case, to organize our code, we're going to need two more files. We're going to need a header file and a second source file. The first source file is this main.cpp file here. To create a new header file, you're going to go into your Solution Explorer and right-click here on Header Files. You'll go to Add, New Item. Here you're given two choices. You can make a .cpp file or a .h file. We want to make a new header file, or a .h file. So you click Header File, and your header file should share the name of your class. Our class is called House, so our header file is going to be called house.h. So a new file was created for us. Your class definition is what is going to go in this file. So we can go over to main and just copy this whole class definition over. Because this class uses strings, we're also going to need this include statement for the string library. And this file is also going to use the standard namespace. The second file we're going to need is another source file. So you can go to Source Files, Add, New Item, and then this file is going to be a .cpp file and should also share the name of your class. In our case, house.cpp. So the purpose of these files is house.h is going to contain your class definition and your function declarations. House.cpp is going to contain your function definitions. Main is then going to use this class along with its functions. However, if I go into main right now and try and make a house object called home, you'll see I'll get an error on house because main does not know what house is. So what we need to do is include the header file in main. And because this is a header file we wrote in the same directory that our source files are in, we use quotes instead of the little arrow brackets. And say include house.h. Now main knows what house is because that house definition is included, and we can make house objects. So now let's get to writing our member functions. I'm going to split these windows so it's a little easier for you guys to follow, and you can do this in your Visual Studio by right-clicking on a tab and then going to New Vertical Tab Group, and it will split your files for you. So I can see house.h over in my right pane and house.cpp in the left. So I said in the last video that we don't like public data. So let's move our data into the private section of the house class. So now that this data is private, you'll see that if I come over to my main function and try and change the street name by using home.streetName equals my street, I'm going to get an error. It says the member street name is inaccessible, and that's because we put it in the private section. So we're going to write some functions that will let us get at that data. When we write public member functions that access private data, there are two types of functions. There's accessors and mutators. They're also sometimes called getters and setters. So I'll have a function which will set my street name or change it, which would be a mutator, and I'll have a function which just retrieves that name for me, which is a getter or an accessor. So the prototype for a function which sets the street name for me might look like this. It's not going to return anything because all we're doing is changing a piece of data in the object. So the return type will be void, and we will call it setStreet. It's going to take a string, and what this function is going to do is it's going to take the passed string and then set street name equal to that string. The prototype for the getter might look like this. It's going to return a string because we're going to reach in and retrieve the street name, and we'll call it getStreet. It won't take any arguments because all we're doing is asking the object to give us a piece of data. Member functions are just like regular functions in that they have to be declared before they can be used. And that's what this is doing. These are function prototypes that are going to be defined later. And we define them in house.cpp. So because we're going to be using this house class, we're going to need to include house.h and house.cpp also. Now let's define the functions. Let's write the setter first. So if this were any other function, the definition would look like this. It would more or less follow the prototype. Okay. But if you look over here, I've still got a green line under setStreet, and Visual Studio is complaining because the function definition for setStreet is not found, even though we have a function called setStreet right here. That's because we have to tell the compiler that this function belongs to the house class. And to do that, we just change the first line of the function definition just a little bit. In front of the function name, you're going to put the class it belongs to, followed by : The way this is read is that this is a function which returns void, belongs to the class house, is called setStreet, and takes a string argument. Now in every member function call, there is an implicit parameter. And that parameter is the keyword this. This is a reference to whichever object is calling the function. That may not make sense right away, but as we start to use these functions, hopefully it'll become more clear. So we use the this keyword to access the data inside the object it refers to. And we use this symbol to do that. That symbol is works nearly identically to the way the dot operator works. In the previous video, when I said home dot num bedrooms, we said that the dot is saying look inside this home object for a member called num bedrooms. This arrow symbol is doing almost the exact same thing. The reason we have to use this arrow instead of a dot is because the this keyword is actually what is called a pointer, which we will learn more about in the next chapter. For now, just think of it as a dot, and this is actually read as a dot. So if I want to change the street name in this object, I'm going to say this dot street name equals name, where name is just the name of the argument that was passed. Some string is passed in. I'm setting this dot street name equal to that string. So now let's write our getter. The getter has a return type of string, belongs to the class house. It's called getStreet, takes no arguments, but this is still an implicit parameter in the function. So what we're going to return is this dot street name. So this is what this says is we're going to return the street name member of whatever object is calling this function. So now I'm going to show you how these work. In the last example, if I was going to set the street name, I would have said home.streetName equals my street. Of course, I'm going to get an error because street name is a private member of the class. So instead, to change the street name, I'm going to call the setStreet function, and I'm still going to use the dot notation like we did in the previous video, and it's going to fulfill the same function. What this is saying is look inside home for something called setStreet, and it looks inside and says, look, I got a function called setStreet, and so that's the function I'm going to call. And we pass a string. In this case, it's going to be called myStreet into the function. So the string myStreet goes into here and is in the variable called name, and then we set this dot street name equal to that string. That string in this case is the string myStreet. How the this keyword works is that in this case, this refers to home because home is the object calling the function. So since home is calling the function, we're going to change the street name in home. I can then retrieve the street name in a similar way, calling getStreet. So I'll say, I'm going to cout this house is on home.getStreet. So when this function is called, it returns this dot street name. In this case, this refers to the home object. And when this function returns, you can just think of this whole piece right here being replaced with the value stored in street name. In this case, that value is myStreet. So when we run the program, we see that we set the street name value to myStreet, and then when we print it, we can retrieve that value calling the getStreet function. Alright, so let's get the rest of these functions written. I want to write an accessor and a mutator for each of the private fields in this house class. First, we're going to write our prototypes. So I'm going to have a set number of bedrooms called set numbeds. It's going to take an int, which I'm going to call num. I'm also going to have a function which retrieves the number of bedrooms called getNumBeds. It's not going to take any arguments because all we're doing is asking the object for data. And again, I'm going to have set numBaths, which also is going to take an int because we're going to be changing a value. And it's going to return void because we're not asking for anything from the object. We're giving the object data and saying, hey, go change this. And get numBaths, which will take no arguments and return an int. Okay, now let's write some definitions. We go over to house.cpp, and the rest of these functions are just going to match the same pattern that we have with setStreet and getStreet. Set numbeds is going to return void, belongs to the house class. Its name is set numbeds. Whoops. Set numbeds. It's going to take an int. And what are we going to do with that int? We're going to set this dot numbedrooms equal to the past int. For the getNumBeds function, we're going to return an int. We're going to make sure that the function name is preceded by the class name and colon colon. getNumBeds, no arguments, and we're going to return this dot numbedrooms set numBaths is going to be identical to set numbeds. Takes an int as an argument, and it sets that int equal to the member variable numBathrooms. And getNumBaths is going to be almost identical to getNumBeds. It's just going to return this dot numBathrooms. And remember that this keyword just refers to whichever object happens to be calling this function. So let's recap real quick. We took our class definition out of main, so that main wasn't so cluttered. We put the class definition in house.h. This definition is going to contain all of the data within an object, as well as the member functions that an object can use. In house.h, these are the member function prototypes. Those functions are then defined in house.cpp. House.cpp needs to include house.h because it's going to use the house class. Main.cpp also needs to include house.h because it is using the house class. So now I want to rewrite main so that we can play with these functions a little more. And I'm going to make it a little more interactive. So instead of using these literals, I'm going to make some variables and then ask the user for information about the house. So I'm going to need a string variable called street and 2 ints, beds and baths. So we're going to print out a question for the user. What street is the house on? And then we're going to use cin to put whatever value, whatever whatever the user types into the variable street. Okay. I'm going to do the same thing for beds and baths. How many bedrooms does it have? We're going to store whatever the user puts in for that into the variable beds. And how many bathrooms? Let's say how many bathrooms. I'm going to put that value into the baths variable. Okay. Just run this real quick, give you an idea of how this is going to go. Say what street is the house is on. It's on my street. Has 4 bedrooms and 3 bathrooms. We don't do anything with that information yet, but that's going to be kind of how this program goes. So once we have this information, I want to change the data in home. So I'll say that home.setStreet. We're going to set the street to whatever the user gave us. What the user gave us is stored in the variable street, so that's the variable we're going to pass into setStreet. Going to set the number of beds to whatever the user input in the beds variable. I'm going to set the number of baths to whatever the user put in the baths variable. And then we can print out some information about the house. Say that this house is on So we're going to get the values for street, number of beds, and the number of baths from the user. We're going to set the corresponding values in our house object called home. Then we're going to retrieve those values so we can print out some information about the house. What street is the house on? It's on my street. So now street in here contains that value. We're going to say it has 4 bedrooms, which gets stored into beds, and 2 bathrooms, which is stored into baths. We set the corresponding members in home, and then we're going to grab them with our get functions and print them out. I guess I should have printed that it has 4 bedrooms and 2 bathrooms. We'll fix that real quick. That's more like it. Enter the appropriate values. Those values are passed to our set functions, which go and change those variables inside home. And then we can use our get functions to retrieve those variables. So let's kind of recap what we did. We better organized our code. We put the class definition in house.h, put our function definitions in house.cpp, and now main only contains the main function. There's nothing else cluttering it up. Remember that house.cpp and main both need to include house.h because they're both utilizing the class. We wrote accessor and mutator functions, which change data and retrieve data for us. And we also went over the this keyword, where this corresponds to whichever object is calling the function. Hope you guys enjoyed the video.